Okay everyone, so we're going to continue our exploration of sketching sine and cosine graphs, but now we're going to focus on when they have horizontal translations. So it's a little more complex than just the dilations, but we should be fine. So let's just recap again the general equation of the function. We have gone through this before, but just to recap again the transformations, remember this is the same for all functions. We still have the same transformations. So the positive or negative tells us if the graph has been reflected, and because it's out the front it affects the y values, so it tells us if it's been reflected across the x-axis. The effect of the a here, we know that's a dilation, and again because it's outside of the basic function that means it's affecting the y values, so it's a dilation from the x-axis. Be careful with your language there, remember we need the word from. And that affects the amplitude. Okay, then we have the effect of n here. It is within the function, so this tells us it affects the x values, so it's a dilation from the y-axis by 1 over n. Remember we need to get that 1 over n, and this affects the period. Now what we're focusing on most today is this negative b here, because this corresponds to our horizontal translations. Or another way of talking about this is that it's been translated along the x-axis. Remember, to determine these translations effectively, we need to make sure, like here, that the coefficient of x is just a 1. Okay, we need the coefficient of x to be a 1 for this to work. The c, the effect of c, we're going to cover that in another session, but c corresponds to our vertical translations, or translations along the y-axis. Okay, so let's look at first thing we need to do, like we mentioned just before, is that we need to make sure that the x has a coefficient of 1. So we need to take the 2 out as a common factor. That means I divide 2x by 2, I get x. I divide pi on 3 by 2, and I get pi over 6. So this is our function that we're going to be sketching. Let's just make a quick list of the transformations. So the square root of 3 tells us it's been dilated by square root of 3 from the x-axis, which we know affects the amplitude. So this is telling us that the amplitude of our function will be the square root of 3. The effect of the 2 tells us that we've been dilated by 1 over 2 from the y-axis. So that affects the period. So we know the period will be 2 pi over 2, or the period will be 2. We can consider our translation, and because we've taken the 2 out as a common factor, that means we can clearly see it's been translated by pi over 6 in the positive x direction. Now, importantly to note, you don't actually need to list all of the transformations, that's not required, but it can be useful. Just particularly to list things like the amplitude and the period. It really helps when we go to sketch our actual function. So we're going to sketch it now. Please excuse the fact that I don't have a ruler. I'm hoping your graph will end up looking much neater than mine, given you'll have all your writing implements ready to go. So just bear with me here. We label our axes. Our period was pi. So we know generally we divide our graph up into 4 sections usually, so we can easily sketch our function. Now this is before we've considered the translation. I'm just looking at what this graph would look like if I was to sketch it without the translation there, just based on the 2 dilations, so we can get an idea of what's going on. Amplitude is square root of 3, so that means we're going from square root of 3 down to negative square root of 3. As I've mentioned before, please do make sure that you're using a reasonable scale. It doesn't need to be the most accurate thing ever, but it does need to be reasonable. If I was sketching this function, let's say I was ignoring the translation. My graph would start at the origin. It would come up to a maximum point at pi on 4. We've got our so we're just putting in our main points. Okay, so we're seeing where they would be. This is if we were sketching without the translation. This is where our points would lie. So we've got an idea of where they would lie without our translation. Now let's consider, so we need to actually translate this, and we need to be moving it pi on 6 units to the right. Now, we can't easily do that because if I'm trying to find the point pi on 6, it's going to be located about here, really. I personally think the easiest way to split this up is to think of this in terms of pi on 12. We'll divide our 0 to pi section up into 12 parts. So by doing this, we can divide it up into 12 sections. Each of them has a size of pi on 12. I've done that so that I can easily move the points I've found along pi on 6 units, which means I'd be moving it along 2 pi on 12, or 2 of these little gaps. So it allows me to find the x-intercepts without having to solve the equation, because if we can avoid solving the equation, it will save us some time. Alright, so originally we had our point at the origin. That's been moved 2 points to the right because it's been translated pi on 6 to the right, which is the same as moving along 2 pi on 12. So I'm counting over 2 of my little segments. I have, oh, it's disappeared. I did before, let me put it up there again. I should have had my maximum point up here. So now we're going to move it along 2 to the right. It used to be here at pi on 4. I'm moving along 2, so it's going to end up further over. My x-intercept at pi on 2, I move that along 2 sections to my new point here. My minimum point was at 3 pi on 4. I move that along 2 points, and we're going to get an end point somewhere around here. So we will have to figure out the value of our end point. So we can substitute in when x is equal to pi, we would get y is equal to square root of 3, 2 times pi, so that's 2 pi minus pi on 3. And we know that 2 pi minus pi on 3, that's the same as saying 6 pi minus pi on 3, which would give us 5 pi over 3. Oh, I've lost sine, haven't I? Where did that go? Let's just come back a minute and, because we're working out sine of this value, sorry everyone, hopefully you've got it all sorted as you're working it out yourself. Square root of 3 sine of, what am I doing? 2 pi, sorry, 2 pi minus pi on 3, which means I have sine of 5 pi on 3. Now we need to work out where this is. So if we're thinking about where I'm going to locate 5 pi on 3, remember we've gone from 0, pi on 2, pi, 3 pi on 2. So 5 pi on 3, that's the same as 1 2/3. So I would be over here in the 4th quadrant where sine is negative. So I'm going to be getting a negative version of whatever my value would have been had it been in the 1st quadrant. And our exact angle values tell us that sine of pi on 3 is equal to root 3 on 2. So by simplifying, square root of 3 times square root of 3 gives me negative 3 over 2, or negative 1.5. So when this is pi, I'll get a value of negative 1.5 just there. Okay, continuing with our other points. I had a minimum point at negative pi on 4. I need to translate it pi on 6 to the right, so I move it over 2 points. Had a point at negative pi on 2. I have to translate that 2 points over. My maximum at 3 pi, negative 3 pi on 4, I translate that, I move that over 2 points. My x-intercept at pi on 2, I'm translating that pi on 6, so 2 sections over. And I'm again going to need another x-intercept, another endpoint. This one though is where x is equal to negative pi. So I substitute this in. This time it will be negative 2 pi minus pi on 3, which is equal to negative 6 pi on 3 minus pi on 3. That gives me negative 7 pi on 3. Now let's think about where we would locate that point. So if we have our unit circle, so I'm travelling in a negative direction, in a clockwise direction, I get around to negative pi is here, negative 2 pi back here, negative 7 pi on 3 is the same as negative 2 1/3, so I'll be in the fourth quadrant, which is like I had for my previous endpoint. So I'm again going to get the negative version of sine of pi on 3, which will give me the same answer as before of negative 3 over 2, which is where I'll find my endpoint here for pi. Finally, we need our y-intercept. So to find our y-intercept, we need to substitute in when x equals 0. So therefore I will get y equals square root of 3 sine of negative pi on 3. Same idea as what I've done every time. I'm substituting in negative pi on 3. So that means that I'm going to be once again in the fourth quadrant like I was before. Once again I'm getting the negative version of what was happening in the first quadrant, and once again I get the answer of negative 3 on 2. So we start to sketch this. Please be careful about the shape. Please think about where your turning points are. And I'm going to do my best to sketch it on the computer, but it might not be my best work. It's going to come down through here. Oh, whoops, not quite, but anyway. Turn. Sorry everyone, this is not my best sketching here. It's a little bit tricky with this software. Let me have another try. Okay, so we come up, we have our turning point, it's going to come down with our turning point, back up, turning point, minimum, end point, and our other end point down here. So again, probably my sketching is not quite ideal. Yours I hope is a bit better. Make sure you've got closed coloured in circles at the end sphere endpoint. Make sure your graph is looking a little bit nicer than mine just here. We can label all of our key points with coordinates. So that's the point pi, negative 3 on 2. We found our intercept here. That was at 0, negative 3 on 2. Our endpoint here, which is actually a little bit low. I think my scale is a little bit off there. But it is at negative pi and 3, no, not 3 pi, sorry, just at 3 over 2. So we've got this value here at negative pi and 3 over 2, negative 3 over 2. Now our intercepts. So if we're thinking about our values here, remember each little part along has a value of pi on 12. So here, pi on 12, the second value is at 2 pi on 12, or 2 pi on 12 is the same as pi over 6 and 0. Now my maximum point here, we're going from, so we had pi on 6, or 2 pi on 12, 3 pi on 12, 4 pi on 12, 5 pi on 12 is the value we're getting to here. 5 pi on 12 and root 3. Now thinking of my next x-intercept, so starting at the previous one at pi on 2, which was the same as 6 pi on 12. Next point over would be 7 pi on 12. Next one again is at 8 pi on 12. And 8 pi on 12, if we're trying to simplify that, is the same as saying, what is it the same as saying? 8 pi on 12, what are we trying to simplify? We can divide both by 4, so it's the same as saying 2 pi over 3 and 0. My minimum point here, minimum point used to be at 3 pi on 4, which is the same as 9 pi on 12. Add 2 to that, I get to 11 pi on 12, and my minimum value is negative square root of 3. We can do the same thing for all of our other points here to get our other coordinates. Negative pi on 4, so it's negative 3 pi on 4 minus another one. We've gone back another way, so that is negative 4 pi on 12. Negative 4 pi on 12, which is the same as a negative, what is it? That was negative 3 pi. Negative 4 pi. Yes, it's the same as negative pi on 3 and 0. Our value here, it was at negative 9 pi on 12. We add 2 to that, negative 7 pi on 12 and square root of 3. And our last value here, negative 10 pi on 12, or negative 5 pi on 6 when we simplify. So we end up with our graph here. Now a few things to note when we're talking about this. First of all, your shape should be a bit smoother than mine, so please take care. I'm sure when you're drawing on paper you'll be able to get a much smoother curve. The next thing to bear in mind is that quite often when sketching these graphs you might be specifically told not to give intercepts, because as you can see there is a lot of work. But if you're not told, or if you're told to label all key features, then you need to do as I've done right here. Third thing to be careful of, use a ruler for your axes and divide up the scale reasonably. Okay? Make sure that your shape looks symmetrical when you sketch it. And always find the endpoints, because we do need to sketch our endpoints. The translations listed here, that's not something that's necessary. You can do it if you'd